Good day guys, welcome to our math series. Okay, so last time we talked about exponents, and for today we're going to talk about the laws of exponents. So how many laws of exponents are there? So I'm going to share to you 7 laws of exponents. Okay, so before we start, I'd like to highlight this. One is exponents. So whenever you see a variable, a base, or a coefficient without a visible exponent, so it's understood that the exponent's 1. Okay, for example, x, you don't see an exponent there, but it's equal to 1. So x is equal to x raised to 1, but we don't normally write the exponent 1 in an expression. Okay, examples, we have 2 is equal to 2 raised to 1, ab is equal to a raised to 1, b raised to 1, and xyz is equal to x raised to 1, y raised to 1, z raised to 1. But we normally write the expressions as 2, ab, and xyz. Okay? Okay, to start with, let's have the product rule. First one, product rule or product law. It says that when the bases are similar or the same, we copy the base and add the exponents. So x raised to m times x raised to n is equal to x raised to m plus n. Okay? Let's go to the examples. 1. We have 2 raised to 4 times 2 raised to 2. Same base, so we copy the base and add the exponents. So copy the base, 2, and then add the exponents. 4 plus 2, 4 plus 2 is 6, so we have 2 raised to 6. And if you evaluate 2 times 2 times 2 times 2 times 2 times 2, we have 64. Okay? Okay, so let's go to the second one. So we have x raised to 8 times x again. This one here, it's got no visible exponent, so we understand that the exponent here is 1. So same base, copy the base and add the exponents. 8 plus 1 is 9, so we have x raised to 9. Okay, next, so we simply multiply the coefficients first, so that's 2 times 3 and that's 6. Okay, so we go to the base now. Same base, copy the base and add the exponent. So we have 2 times 3, x raised to 2 plus 3. Okay, copy the base, add the exponents, and there we go. So let's move forward. We have 2 times 3, 6, and add the exponents, x raised to 5. Okay, so this is our final answer. Okay, so the next one, we have the quotient rule. Next, we have the quotient rule. It says that with the same base and different exponents, you just copy the base, subtract the exponents. Okay, thus x raised to m divided by x raised to n is equal to x raised to m minus n. Okay, let's go to the examples. First one, 3 raised to 4 over 3 raised to 2 equals. So we've got the same base, we copy the base. Okay, 3, copy 3, and then subtract your exponents. 4 minus 2, so we have 3 raised to 4 minus 2, so we have 3 raised to 2. 4 minus 2 is 2, and then 3 squared, you know it's equal to 9. 3 times 3 is equal to 9. Okay, next, so what do we do here? We divide the coefficients. 10 divided by 5 is 2, and then do the quotient rule. Same base, copy the base, x, and then subtract the exponents. You have 4 and 1, 4 minus 1. Okay, so when we write them down, you still have here 10 divided by 5, copy the base, x, and then subtract 4 minus 1. So now we can divide your coefficients or the numbers, the whole numbers. So 10 divided by 5 is 2, and then x raised to 3, because 4 minus 1 is 3. Okay, next one. So we have a more complex one. We've got 2 variables, x and y. So we have 4 x raised to 4 y squared over 2xy. So we divide the numbers. So we have 4 divided, so we have 4 divided by 2, and then do the quotient rule here. So same base, copy the base, subtract the exponents. 1 is the exponent because it's not written, it's not visible, so 4 minus 1 there. And then y, copy the base, y, and then subtract 2 and 1. That's why you've got 2 minus 1 there. So to simplify, we have 4 divided by 2 is 2, x raised to 3, and y. 2x cubed y. Let's go to the third one. It's power of a power. So we have power of a power. So power, it's an exponent raised to another exponent. So we have quantity x raised to m, quantity raised to n. So we just copy the base and then multiply the exponents. That's why it's m raised to n there. Okay, so let's move on. Examples. So we have quantity x squared raised to 4. So we just copy the base, which is x, and then multiply the exponents, 2 times 4. So we have x raised to 2 times 4, or 4 times 2, and your answer is x raised to 8. Okay? Example number 2, you have 2 squared, quantity squared. So just copy the base, you have 2, and multiply your exponents. 2 times 2, you have 4, and then simplify this expression. 2 times 2 times 2 times 2, you have 16. Okay, moving on to the fourth one, we have the power of a product. The next one, we have power of a product. So inside your parentheses is a product. Okay? And then it's raised to a certain power or to an exponent. That's why it's called power. Power is your exponent, and then whatever's inside the quantity or the parentheses refers to the product. So how do we express this one? So we just distribute the exponent to your variables or to your coefficients or the numbers inside the parentheses. So we have quantity x, y, quantity raised to n, distribute n to x and to y. That's why x raised to n, y raised to n. For example number 1, we have quantity 3 squared, quantity cubed. Okay, so this is actually power of a power, but we proceed. So sorry about that. So we copy the base, 3, and then multiply your exponents. So 3 raised to 6. Okay, 3 raised to 2 times 3, 3 raised to 6, and then simplify, you have 729. Okay, so let's move forward. We have quantity 2ab squared, quantity squared. Okay, so we distribute this exponent into which coefficient or variables in the quantity or in the product. Okay, so if we write them down, you have 2 squared, a squared, and b raised to 2 times 2. So to simplify further, so when you simplify, you'll write 2 squared is 4, a squared, and b raised to 2 times 2, that's 4. So your final answer will be 4a squared, b raised to 4. And then the fifth one, we have power of a quotient. We have power of a quotient. So it's the division form of the one earlier, power of a product. So power refers to your exponent and quotient refers to your division operation. So we have quantity x over y, quantity raised to n. We just distribute your exponent to your numerator and to your denominator. So you'll have x raised to n and y raised to n. Okay? So x raised to n over y raised to n. Examples, we have quantity a over b, quantity cube. So distribute your exponent to your numerator and then to your denominator as well. So it's equal to a cube over b cube. Okay? So that's 1. Number 2, we have quantity 3x over 3y cubed, quantity squared. So we distribute your exponent to the numbers and letters in your quantity. Okay, so we write 3 squared x squared over 3 squared y cubed times 2. Okay? If you remember your power of a power, that's why it's like that. 3 times 2. So that dot sign there is a symbol of multiplication. So if we do the shortcut, we can just cancel 3 squared and that becomes 1. But if we do the long cut, so 3 squared is 9, x squared over 3 squared is 9, y raised to 3 or y cubed times 2, 3 times 2 is 6. And then we can just cancel 9 as well. So that becomes 1 and we don't write 1 in our numerator. So we just write x squared over y raised to 6. So we can no longer simplify this one because our variables are different. Okay? So let's go to the sixth one. What would be the answer if the exponent is 0? Next, we have 0 exponents. So we have x raised to 0 is equal to 1, provided that x is not equal to 0. Because in our previous vlogs, in our previous math series videos, we said that 0 raised to 0 is indeterminate. Okay, so as long as the value of x is not 0, then the answer is 1. Okay? Okay, let's go to the examples. A raised to 0 is 1. 2 raised to 0 is 1. Quantity negative 2 raised to 0 is 1. Whereas negative 2 raised to 0 is negative 1. So what's the difference between this one on your left and this one on your right? The negative 2 on your left has got a parenthesis outside. So we're raising the whole quantity, including the negative sign, to 0. That's why the answer is 1. On the other hand, the one on the right, we're just raising the number 2 itself to 0, leaving the negative sign. That's why the answer is negative 1. Okay? So quantity PQ raised to 0 is 1, and quantity 5a squared b cubed raised to 0 is 1. Okay guys, here's the last one. We have negative exponents. Next, we have negative exponents. So it says, when your base is raised to a negative number, x raised to negative n, do the reciprocal. So in fraction form, x raised to negative n is x raised to negative n over 1. So the reciprocal for this expression is 1 over x raised to n. So if you notice, we've changed the sign of the exponent from negative to positive. Okay, so equally, if you see 1 over x raised to n, that's equal to x raised to positive n, because we've changed the negative exponent sign into positive. As a technique, I can just say that if I see a numerator with a negative exponent, I can move it into the denominator, changing the exponent sign from negative to positive. At the same time, if I see a negative exponent in my denominator, I can move it to the numerator part and change the sign into positive. Okay, so how about in here? So we have quantity x over y raised to negative n. We just distribute negative n to your numerator and to your denominator. So that's x raised to negative n over y raised to negative n. And then, as what I've said earlier, the numerator with a negative exponent goes down to the denominator, but we have to change the negative sign into positive. Equally, the denominator with the negative exponent goes to the numerator, and we change the negative exponent sign into positive. Thus, you get y raised to n over x raised to n. So examples, we have a raised to negative 5. So a raised to negative 5 over 1. Your reciprocal is 1 over a raised to positive 5. So we just move this part here into the denominator, changing your negative sign into positive. Okay? And then you have 4 raised to negative 2 over 1. So your reciprocal is 1 over 4 squared. So in the process, we've changed the sign from negative to positive. And then if you simplify 4 squared, so you get 1 over 16. Okay? Next, you have x raised to 9 times x raised to 5.
you just move x raised to 5 to the denominator, so the sign becomes positive by then, changing the sign into positive 5, so you'll have x raised to 9 over x raised to 5. Okay, so why is x raised to 9 in the numerator? Because it did not have the negative sign, so we keep it as your numerator. Only this one has a negative sign, that's why it's the only one we've brought down to your denominator. And then following your quotient law or quotient rule, same base, copy the sign, subtract the exponents, 9 minus 5, you got 4. So your final answer is x raised to 4. So we'll distribute your exponent, negative 3, to your numerator and to your denominator. So if we simplify, we have c raised to 2 times negative 3, 2 times negative 3, that's negative 6, over d raised to negative 3. It's not yet the final answer. We have to simplify your negative exponents. Just like what we've said earlier, the numerator with the negative exponent goes where? Yes, it goes to the denominator part. And then your denominator with the negative exponent goes to your numerator part. So you write d cubed or d raised to 3 over c raised to 6. So we have a raised to negative 2 b cubed over c raised to negative 4 d raised to negative 1. So again, just move the expressions with the negative exponents to your numerator and then change the exponent sign into positive. This numerator with the negative exponent goes into your denominator part and then changing the sign into positive as well. Thus we write b cubed. So how come b cubed still up there? Because it's got no negative exponent. So we just copy it in our numerator side. And then a raised to negative 2 becomes a squared. Okay, take note of the sign change from negative to positive. And then c raised to negative 4 becomes your numerator as c positive 4, and d raised to negative 1 will be written as d because we don't normally write d raised to 1. Okay, and that's your final answer because you've got different variables. Okay, a, b, c, and d. So we can no longer apply any other exponential laws there. Okay, and then we have one more. We have negative 4x raised to 5 y raised to negative 2. So again, we have one variable with negative exponent, so it goes down as your denominator and you keep the rest in the numerator part. So we have negative 4 x raised to 5 over y squared. Okay, so it's only this expression we've moved to your denominator part. Okay, so that's your final answer.
Okay, so before we end, let's answer some exercises.
So let's move to the exercises. So s raised to 0, 0 exponent is equal to 1. And then x raised to 4 times x raised to 2, product rule. Same base, copy the base, and add the exponent. So 4 plus 2 is 6. Next, you have 45z raised to 4 over 15z. So quotient rule, divide the numbers. 45 divided by 15, you have 3. And same base, copy the base, z, and subtract the exponents. So 4 minus 1, because your denominator's exponent is 1. It's not written. So we have 3z cubed. Next. So we have quantity g raised to 4, quantity raised to 4. So power of a power. Copy the base g and multiply the exponent. So 4 times 4, and yes, you have 16. So g raised to 16. And then we have quantity 9c squared, quantity cube, power of a product. So we just distribute your exponent to your coefficient and variables in the expression. So we have 9 cubed c raised to 2 times 3, and that's 729. 9 times 9 times 9 is 729, and then c raised to 2 times 3, 2 times 3 is 6. Next, we have quantity 4m over 2n cubed, quantity squared. So we have power of a quotient. So we have 4 squared m squared over 2 squared n raised to 3 times 2. So we have 4 squared is 16, m squared over 2 squared is 4, n raised to 3 times 2, 3 times 2 is 6. And then we can still divide 16 by 4. 16 divided by 4 is 4. Then we get 4m squared over n raised to 6. Okay? So m and n are different variables, therefore we can no longer simplify this expression. Next, we have negative exponent rule. We have c raised to negative 6 over d raised to negative 3. So our technique earlier, move the numerator with the negative exponent to your denominator and move your denominator with the negative exponent to your numerator. So we're just doing the reciprocal method. So we have d raised to 3 over c raised to 6. So note the change from the negative sign to positive sign. Okay? Next, we have 9f raised to 6 over 3f raised to 3. So you can see on your denominator, you have a negative exponent. So we can just move it to your numerator. So we have 9f raised to 6, f cubed. Okay, we've moved f raised to negative 3 to your numerator. That's why it's now f raised to 3 or f cubed all over 3. Then we simplify. We have 9f raised to 9. We've done the product rule, same base f, copy the base and add the exponents. So f raised to 6 plus 3, you have 9 over 3. So just divide 9 by 3, you have 3f raised to 9. Okay?
Okay guys, so this concludes our video for today. Thank you very much for watching. If you like the content of this video, don't forget to click the thumbs up button, consider subscribing and hit the bell icon for future updates. I'll take this opportunity as well to thank Ate Susan Trinidad of Susan's Kitchen. Thank you very much for your delicious meals. Thank you ever so much. If you like to order from her, be sure to connect with her Facebook account displayed on your screen. Also, thank you very much to Chanel Manzanillo for Leon's 10th month cake. If you'd like to order some sweet stuff or cakes, be sure to contact Chanel and here's her Facebook details. And also to my colleague Irene Fandalian, hi there, thank you very much and massive shout out to you as well. Thank you very much for your Sensible sample and we're looking forward to tasting more of your creations. Okay, stay safe. Okay guys, so that's all for today. Thank you very much for your support. Thank you very much for watching. So I'll see you in our IELTS series as well as in our healthcare series. So stay safe and God bless you all. Bye!